All right, so day 3 of factoring. Today we are going to learn the dots method of factoring, which is the difference of two squares. So first let's talk about what is a square. And for the dots method, we are going to look at what a perfect square is. So a perfect square is a number, for example, like the number 9, right? When I can take 3 times 3, that equals 9. Another perfect square would be 36. 6 times 6 equals 36. So the perfect square is when I take the square root of a number and it is a whole number. So the dots method, what we're looking at here is factoring when I have a perfect square. So what this would look like is something like x squared minus 9. So to factor that, I am going to have x plus 3 and x minus 3. So whenever you have x squared minus a perfect square, you are going to get a plus and minus for your factors, and you're going to use your perfect square numbers. So if we did another example here, let's do x squared minus 36. I'm going to have x plus and an x minus, and the square root of 36 is 6, so I can plug that into my factors. So that is the dots method. The key here that you have to look for, and you always want to look for this, is this has to be a negative sign here. Okay, so for the dots method to work, it has to be x squared minus your number. It has to be a minus here. Okay, if you ever have x squared plus, let's see here, let's write this on the side here. If you have x squared plus your number, you cannot factor it. And when you cannot factor something, it is called prime. So as you go through this, it is nice to have some of your perfect squares memorized. You're not going to be tested on that. You have them memorized, but it just makes the process faster. So it's helpful to know our perfect squares. So if we have our perfect squares, we have the number 1, right? 1 times 1. We have the number 4, 2 times 2, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, right, etc. Usually we have 1 through 12 memorized. So this is like saying 1 times 1, right? 36, 6 times 6, 81, 9 times 9, etc. So a couple examples using dots. So let's do x squared minus 25, and we're asked to factor. So I look at a couple things. First, I'm going to notice, oh, it's a plus sign, and 25 is a perfect square. So I'm going to have x plus 5 times x minus 5. That's it. Right, just to show you, to check your work, you would have x squared plus 5x minus 5x minus 25. Combine like terms. In the plus 5x and minus 5x cancel. So So that's where we get to our original answer, right? So these connect, they're the same thing, so we know our factors are correct. Okay, if I asked you to factor x squared plus 64, first thing we're looking for is that negative sign. So it's not a negative, it's a positive. So this is prime, okay, which prime again means we cannot factor. All right, and another example would be if we have x squared, or 9x squared minus 64. So here, again, I'm looking, I have a negative sign, so I'm going to factor it. Okay, one's positive, one's negative. So if we have 9x squared, I can factor 9 as 3 times 3. So I have 3x and 3x. Minus 64, I'm going to have plus 8 and minus 8. So see how if I have this first value here, as long as that's also a perfect square, I can use the same concept. And that is your notes on the dots method, the difference of two squares.